Okay, so let us now have another example here. So for illustrative problem 3, given the following parameters, we would now be determining the following. So we would be determining the nominal strength and the design strength of this particular beam. So the first thing that I will do is that I will be drawing what the beam would possibly look like. But then again, I will not draw the details of this. And instead of drawing 8 pieces of 28 mm rebars, I would just draw one whole rebar here that represents the hole. Okay. So when I say whole, I mean W-H-O-L-E, whole 8 pieces, not whole as in butas or H-O-L-E. Anyway, so with that being said, so it is given in the problem that the beam width or the beam breadth is actually equal to 300 millimeters. So 300 mm. Then the effective depth, so meaning by effective depth, that is the distance from the top up until the centroid of all of the rebars. And with that, this is now equal to 420. Okay, so that is now 420 millimeters. Okay, so what else? So as you can see here, we now have this new parameter, which is the distance from the top to the bottom bar center. So what is its difference with the beam effective depth? So its difference with the beam effective depth is that given this parameter here, this is the effective depth and this is now the depth up until the furthest bottom bar. Okay, so basically in this sample, this is dt. So where do we use dt? dt should actually be our basis for, in order for us to solve for the value of p later on. Okay, so why didn't we use that in our previous example? So the reason why we didn't use that in our previous example is because that it was not even given. Okay, so if it is given, of course, you would be making use of it. If not, then, well, what choice do we have? Okay, anyway, so again, that is 300, 420. Then for F prime C, that is equal to 35 megapascals. Then for rebar, Fy, of course, that is 280 megapascal. Okay, so again, recap that for the nominal moment, Mn, M sub n, that is equal to, so it is either you would be getting the moment at the compression side or at the tension side, but once again, I think it would be better if I would be drawing the stress diagram here. Okay, so suppose once again that the compression concrete would now be this one here. So meaning that this is now the uniformly distributed load. Okay. And once again, this is 0.85 F prime C. And from that, this is now the value of A. Okay. So again, that is now the value of A. And at the tension side, so suppose that this is now the centroid of them. So once again, this is AS, FS. So for the moment, nominal moment, if you would be getting the moment about the tension side, so meaning that this is now equal to 0.85 F prime C times A times B sub W times D minus A over 2. Or if you would be getting the moment about the compression side, it means that this is now our lever arm and this is now our tension. So from that, this is now equal to AS FS times D minus A over 2. So once again, where did we get D minus A over 2? So if this is the center, so if this here is the center of the value of A, if you would be getting the lever arm here, so this value of the lever arm is basically equal to D minus A over 2. Okay, so thus D minus A over 2. And same problem, we still need to get the value of A here. So in order for us to get the value of A, we can get the summation of forces horizontal equal to 0. to the right positive, for example. And let's say from that, C is equal to T, or compression is equal to tension. So rewriting all of them, so that is now equal to 0.85 F prime C times A times B sub W. This is now equal to AS times Fs. So what is now the value of F sub S or Fs? So since we are already given this parameter, so we already know the number of rebars here, it would be better if we would once again get the rho and compare it with rho balance. So let's check. Okay. So for the value of rho, same thing, that is AS times B, AS all over B sub WD. So with that, this is now equal to, so how many pieces are there? I think there are 8. There is 8. So 8 times pi over 4 times, what is the bar diameter? So the bar diameter is 28. So times 28 squared. And BWD, so for BW, that is 300. So 300 times the effective depth. Take note, effective depth. So meaning that is 420. So 420. Okay, so using our calculator, so that is now equal to 8 times pi over 4 times 28 squared divided by 300 times 420. So our rho is now equal to 0.3909 or 391. Okay, so what about for rho bal? So for rho balance, so this is now equal to 0.85 times F prime C over Fy times beta 1 times 600 over 600 plus Fy. And take note, for our value of beta 1, so take note, since F prime C is now greater than 28, it means that the value of beta 1 is not equal to 0.85. So with that being said, guys, either you make use of this particular logic. So where was that? So it is either we make use of the logic that I have defined for earlier. Teka, nasan yun? So in here. So for F prime C equal to 35 megapascal, our beta 1 should be 0.8. So why did that happen? So if you can be seeing this, or if you are to use this equation, so that is now equal to 0.85 minus 0.05 times F prime C, and our F prime C is 35 minus 28 divided by 7. So that gives us an answer of 0.8. Okay, so from that, our beta 1 is equal to 0.8. Okay, so from that, for our rho balanced, this is now equal to 0.85 times 35 divided by Fy. I think our Fy is 280, but to make sure, so once again, that is 280. So divided by 280 times beta 1 of 0.8 times 600 over 600 plus 280. Okay, so from that, our rho balance is now equal to, looking at the calculator once again, so 0.85 times 35 divided by 280 times 0.8 times 600 divided by 600 plus 280. Okay, so our answer here is 0.058. And if we would now be comparing the rho of 0.391 by the rho balanced of 0.058, since as you can see here that the actual rho is less than rho balanced, meaning that it lacks steel rebars for it not to yield, so meaning it would yield, and thus there it will yield. And from that, Fs is now equal to Fy. So from that, um, from our summation forces horizontal is equal to 0 once again, whereas C is equal to T. So 0.85 times F prime C times A B W is now equal to, instead of us writing ASFS, we would just be writing ASFY. So substituting known values, so this now 0.85 times F prime C, which is 35, times an unknown A, times 300. Wait, was that 300? I forgot once again. So 300. So this is now equal to AS, and AS is now equal to 8 times pi over 4 times 28 squared times Fy of 280. So let me check if all of them are correct. So 8 pieces 28, 35, 280. Okay, so solving for the value of A, this is now equal to, so 0.85 times 35. Oops, sorry. So this is now equal to, so 8 times pi over 4 times 28 squared times 280 divided by 0.85 times 35 times 300. Okay, so the value of A is now equal to 154.542 millimeters. Okay, so since we already know the value of A, we can now proceed with getting the nominal moment. So for the nominal moment, Mn, that is now equal to, it will be up to you which equation you will use. So I will make use of AS Fy times D minus A over 2. So from that, AS is equal to 8 times pi over 4 times 28 squared times 280 times D. So our value for D is 420. So 420 minus A over 2, which is 154.542 over 2. So from that, M sub n is now equal to, so 8 times pi over 4 times 28 squared times 280 times 420 minus 154.542 over 2. So 8 times pi over 4 times 28 squared times 280 times 420 minus 154.542 divided by 2. So this is now equal to 472720913.5 Newton millimeter. So if you would now be dividing this by 1 million, the answer would be, 1 million I should say. So divided by 1,000 divided by 1,000, that is 472.721 kilonewton meter. So this is now its nominal moment. So in order for you to check, you can make use of the other formula, being this. So let us try, but I would not write it any longer. I will just direct it to my calculator. So 0.85 times F prime C of 35 times A. What was our A again? So our A is 154.542, then times BW of 300, so times 300 times, so again we are referring to this equation here, so times 420 minus A of 154.542. Okay, so to confirm, this is now its nominal moment if you would be making use of the other equation. Again, they are basically the same. Okay, so that is now our nominal moment. So next up, the design strength. So design strength once again is Vmn. So our issue here is what is now the value of phi. So for the value of phi, we would now be making use of, well, actually it will be up to you if you would now be making use of, where was that? Of the graph of the strain in here. Or if you would be making use of the graph of strain. I'm sorry. So it is up to you if you would be making use of the graph of strain, if you would be making use of the graph of stress, or if you would just make use of the formula. Once again, I really like making use of this graph here. Okay, so since we need the value of Fs here, so again, if you can remember that F sub S is equal to 600 times D minus C all over C. Okay? But since in our problem here, it is already given that, dt is already given, meaning guys, that if dt is given, change this into dt. Again, if it is not given, just use d. And if it is already given, use dt. So from that, the stress or at the furthest tension fiber is equal to, so 600 times dt, and our dt is 434, minus c. So I forgot to solve for the value of c. So for the value of c, I would just be moving this downwards here. So for the value of c, so it is now dependent upon the value of a. So 154.542. So c is basically equal to a over beta 1. And from that, a is equal to 154.542 divided by beta of 0.8. So substituting known values or calculating them, so 144.542 divided by 0.8, it would now give you an answer in 193.1775 millimeters. So from that, substituting them here, oops, sorry, I forgot to erase my previous solution. Okay, so once again, 434 minus 193.1775 divided by 193.1775. This is now equal to, so F sub S is now equal to, or we can actually rename this as F of T. So in order for you not to get confused, okay? So since we have changed this into dt, we can actually change this as F of T. Okay? So anyway, so this is now equal to, so 600 times 434 minus 193.1775 divided by 193.1775. That would give us an answer of 747.983 megapascal. Okay, so this is now our FT or FS. So, but once again, it would be more appropriate if you would be making use of the term FT, or that is now the stress at the furthest tension. So meaning it is now the stress being experienced by this extreme tension rebars. Okay, so once again, if we are now to make use of this value in this graph, so meaning that it is higher than Fy. So once again, the Fy in our problem is 280 megapascal. And for tension control, that should be 1000. But since, as you can see in my calculator below me, the Fs is 747. So it is approximately here. So I'm not sure where exactly, but it is approximately here. So with that being said, if it is here, you can make use of interpolation. So I will be showing you two ways. The first way is by manual computation, and the other way being a calculator technique. So again, if you would now be interpolating this, let us just have this particular triangle here. So if, let's say, for example, if Fs is equal to 1000 megapascal, the value of phi is 0.9, correct? Okay. But if the Fs is 0.65, or sorry, if the Fs is 280 in this case, then meaning that the fee is 0.65. So this is now our ratio. So 1,000 minus 280 divided by zero point 0.9 minus 0.65. So these are partners and these are also partners. Then you would now be equating this to. So you can now write your FS here or FT. So this is now 747.983 minus 280. So this is also equal to, what is the partner of 747.983 in this case? So actually, we do not know what the value of fee is here. So from that, just write here fee. So this is now subtracted by 0.65, which is the partner of 280. So from that, the value of fee is now equal to, so looking at the calculator, so this time I would just be making use of shift solve. So, So 1,000 minus 280 divided by 0.9 minus 0.65. This is now equal to 747.983 minus 280 divided by P or alpha x minus 0.65. Okay, so shift solve. Solving for x, our phi is now equal to, so can solve. Why is that the case? I think I did something wrong. Okay, so apparently my calculator does not want me to solve for it via shift solve here. So with that, guys, I will just simplify our equation here. So from that, this is now equal to, so 747.983 minus 280 divided by, or times the ratio of, so again, what I did was I have cross multiplied this, and from that, this is now 0.9 minus 0.65 divided by 1,000 minus 280. So this is plus 0.65. Okay, so I will try to solve for it using this method. So what I did was I have just cross multiplied. So from that, 747.983 minus 280 times 0.9 minus 0.65 divided by 1,000 minus 280 plus 0.65. So my answer here is 0.81249. Okay, so if you would now be making use of the equation by NSCP, so this is basically it. So 0.25 plus 0.25 times, just solve for the strains. And from that, guys, you would still be arriving at the same answer, which is this one here. So another shortcut is that instead of us creating an equation this way, we can just make use of stat mode. So for stat mode, just click on mode, then 3, mode stat. So stat mode, then go to the second one, or the linear interpolation. So from that, I will now write the known data. So what I know here, so in this particular slope here, I know that when x is equal to 1,000, which is this, I know that y is equal to 0.9, which is this. And when fy is equal to 280, since my fy is 280, when x is equal to 280, I know that y is equal to 0.65. So I will be writing this down, or I will be typing that to my calculator. So again, if x is equal to 1,000, my y is equal to 0.9. If my x, or if the value of x is equal to 280, I know that the value of phi, or the value of y, is 0.65. So upon doing this, you can now press AC. You can clear it. Now you can go to the stat mode. So that is shift 1. Then go to the registry, or 5 reg. And then 5 y caret. So what this does is that if you would be typing the value of x, he will now solve for the value of y. So since we know this particular value, which is 747.9, what was that again? 0.983. So what we will be doing is that we will be typing 747.983 y carat. So um, our calculator will now solve for the value of y. And from that, upon pressing equals, we would now be arriving at the same exact answer as what we did earlier. Again, if you want to solve for it via the formula indicated in the book, feel free to do so. But if I do not like, I am also free to do what I like. And if you do not like to do that also, then do not do that. Okay, so again, where is my solution? Not that. So again, for the value of mn, the value of mn in our solution here is 472.721. And we have already solved for the value of phi, which is 0.81249, which is in the transition zone. So from that, phi mn is now equal to 0.81249 times 472.721, which is this. Okay, so from that, just multiply this by 472.721. And our answer here is 384.08 kilonewton meter. Okay, so there.